All right, we are going to start in with section 7. And so I'm going to give this warm up. So go ahead and pause and get the correct answer, and then we'll check it. So the answer on this would be 5 squared, because the top number is squared, and then the bottom number is a square root. So that would mean that I'm looking at the index, and I'm looking here. So that would be, the answer to this would be D. Okay, so try 2. This would be no calculator. I'm going to pause, and then you're going to do it. So I should know the 4th root of 16 is 2. So 2 cubed is 8. So that's my answer on this one. On this one, pause and try it. 25 to the 1/2 is 5. 64 to the 1/3 is 4. So my answer is 5/4. On this one, pause and do the question. So this ends up being W to the 14 sevenths, because you would add exponents when you multiply. Well, 14 sevenths is 2, so this would be W squared. Okay, now we talked about this yesterday. Everything we did yesterday was with 2's, but you can rewrite 100. So this is the 4th root of 10 squared. That's the smallest I can make it. So it might be easier to write this in exponential form, because that would be to the 2/4, which ends up being to the 1/2. That would be the correct answer, but if you look at my answers, none of them are that. Since it started in radical form, then this answer must be in radical form. So that would be the square root of 10, which is A. All right, so we're going to start this, and this is going to be the first time in your math career that, because we're dealing with something that is not all real numbers, and that's the first time you've done that when you're solving, we're going to deal with something that might not have solutions. Okay, and I wish that I should have made this an X, so I'm just going to go ahead for the sake of it and make this an X. Okay, if I think about this problem and I look at it on a graph, and this is saying go right 2 and go down 1, and there's my point. And then I would go over 1, up 1, and there's my point. And then I would go over 4, 1, 2, 3, 4, and I would go up 2, because that's the square root of 4. And I would keep doing that, right? Oh, gosh, someday I'm going to learn to draw. This looks like a parabola on its side, so it's going to do that. And if I made the line, so that's this side. So if I made my line y equals 5, and just use like purple, that's going to be going across here. At some point, this is going to get higher and higher, and they're going to hit. So I am going to have an answer on this. But this is the first time you're going to have, you're going to get an answer, and it may not work. So you're going to do the math, and mathematically, I'm telling you right now, these are easy. I would take mathematically. I did not say these problems are easy. I said mathematically they are. I would add 1 to both sides. So that's going to be the square root of x minus 2 equals 6. So then what's the opposite operation of square rooting? You would square. So you would get x minus 2 equals 36. And then I would add the 2. So my answer is 38. And so if I could stretch this graph over to 38, that's where these guys would hit. Okay, so you're not always going to be able to graph it, and because they could be more complicated, but when you're doing these problems, I'm going to say to you, you have to check. It's not an option. You have to check, because what you got may not work. 38 minus 2 minus 1. So this would be 36, and the square root of 36 is 6, so my answer is 5. So it does work. We are going to learn what is called, I was going to write down a trig vocabulary word, sorry. We're going to learn what's called an extraneous solution. And what that means is that it mathematically works in the equation, but it doesn't work when you plug in the answer. And this one works. So my answer on this is 38. I'm good to go. Okay, so let's take a look at this one. So if I were to graph these, okay, I'm going to graph this side, and I'm just sketching it. I mean, oh, no, I don't want that. I'm going to graph this side, in pink. So this is x minus 12 inside of there. So this is going to be way back there at 12, and it's going to go like this, right? And then if I graph my other one, I graph this side, it is shifted up 2, 1, 2, and then because of the negative, it's flipped down. Look at these two graphs. Does the pink graph ever hit the green graph? No, they don't. But you're going to have to mathematically show me that. You're going to have to get the correct answer and then show me. But at least we know right now before we start this problem, it's not going to work. And so you can do that before. I'm going to do the next one and I'm going to do it at the end. So either way. So how do you get rid of square rooting? You square. So the left side becomes x minus 12. But we've been doing this all semester. The right side, you're going to have to FOIL this. So you end up getting, let's see, 4 minus 2 root x minus 2 root x plus the square root of x squared. So wouldn't that just be x? All right, so if I put my like terms together, I would have x minus 12 equals 4 minus 4 root x plus x. So now I need to get my stuff on the same side. So I'm going to minus x from both sides. Okay, my x's cancel. And so that leaves me with a negative 12 equals 4 minus 4 root x. So now I'm going to minus 4. And I get a negative 16 equals a negative 4 root x. I divide by a negative 4. And I get 4 equals the square root of x. And then I square both sides. And so x equals 16. So I just got an answer. I got 16. And on the test, I'm going to be looking for that answer. But if I take this 16 and I plug it back up here, I would have the square root of 16 minus 12 equals 2 minus the square root of 16. So this side is 4. The square root of 4 is 2. This side is a negative 2. Does 2 equal a negative 2? No. So that means that this answer is what we are calling extraneous. Because what that is saying is that that 16 is an answer when I do the algebra, but when I put it back in, you can look at the graphs, they don't hit each other. Honestly, what that 16 would be, and you can see this really well on a graphing calculator, is it would be the other part of that answer if this was flipped. Okay, so what you would write is 16 is your extraneous solution, so there is no real solution to this problem. Okay, so on the test, you can't just graph these and say it doesn't work. You're going to have to find the mathematical answer. Okay, so I would like you to try this, pause it, and try this one on your own for scratch paper. Okay, and then unpause it when you're done, and I'll work it out. So then you'd square both sides. And then you would add the 3, and so you get 67. You must take the 67 and plug it back in and see if it's extraneous. So 67 minus 3 minus 2 on the outside, that's 64, which is 8 minus 2. Does that equal 6? Yes, so 67 is my answer. Okay. So try this one. It's practice. I'm going to square both sides. So I get x plus 5 equals negative 1 minus root x and a negative 1 minus root x because I'm squaring it. So that's going to be, I don't know why I used parentheses. Hold on. I did it again. So that's going to be 1 plus root x plus root x plus root x squared. So that's just going to be an x. And so I'm going to put like terms together. Those would be 1 plus 2 root x. But then if I minus my x to the other side, those x's are going to cancel. And will they always cancel? No. Will they always cancel in this class? Yeah, probably. So I'm going to minus 1 and I get 4. You must divide by 2 before you get rid of the square root. So square root both sides, and my answer is 4. Now I need to check my answer. So I'm going to take that 4 and I'm going to plug it back in. So I'm going to have 4 plus 5, that's the left side, and then a negative 1 minus the square root of 4. 4 plus 5 is 9, the square root of that is 3, and then this would be a minus 1 minus 2, which is a negative 3. So this answer does not work, so it's extraneous. Okay, so on the test, I'm going to say, state your extraneous solution. So this has no real solution, and my extraneous is 4. Now, because I've done these two examples and they don't work, kids just assume they always don't work. We're going to do some that work. And if you graph this, the left side would be, I would go left 5 and it's going this way. The right side is down 1 and it's flipped down. So if you look at those two graphs, they're never going to hit. All right. Now you can cube root everything. So this one really isn't going to be extraneous, but you can check it if you want. So what I'm going to do first is I'm going to move the 5, and so the 5 goes over here. How do I get rid of the cube root of something? You're actually going to cube both sides, because then that would cancel it. So I have 3y plus 1 equals 125. So then I get 3y equals 124, and divide by 3. I don't think it goes in evenly. 6, 7, it doesn't. So I'm just going to say 124 thirds. And so you can check that if you want, but I do know it's going to work because it's a cube root, and you can cube root negative numbers and positive numbers. Okay, so example 4, try this one, pause and try it, and then I'll work it. So then you're going to take and you're going to cube both sides. So I'm going to minus the 1 and divide by 2. So my answer is 13. You can check it if you want. 2 times 13 is 26 plus 1 is 27. The cube root of that is 3. 3 minus 3 is 0. You can check it, but you only have to check even roots because those are the ones that not everything works. Okay, and this, what did I just say? You only have to check even roots. That's an even root, so we're going to have to check this one. So I would start by adding 4. I don't know why there's parentheses there. And then I'm going to divide by 7. And then how do you get rid of 6th rooting something? You're going to take it to the 6th. And you should know how to do 2 to the 6. Use your fingers. 2, 4, 8, 16, 32, 64. So my answer is 64. So then I'm going to minus the 4 and divide by 5. So my answer is 12. You must check this because it was an even radical. So I would do the 6th root of 5 times 12 is 60. 60 plus 4 is 64. And the 6th root of that is 2. So 2 times 7 is 14. 14 minus 4 is 10, which is what it says it should be. So this is the answer. This is not extraneous. You do not have to check this one because it is a cubed root, but you can if you want. So you're going to add 4 to both sides. So you get 9 cube root of 3h plus 3 equals 81. So I'm going to divide both sides by 9. So I'd have the cube root of 3h plus 3 equals 9. Okay. So how do you get rid of square rooting something? Or cube rooting something, you're going to cube. And so that's 729. I don't have a calculator here. So now I'm going to minus 3, and that's 726. I don't have a calculator. So divided by 3 goes in there twice with 1 left over, 4. So 242. And you can check it if you would like, but I do not have to because it's a cube root. So everything goes into a cube root. You only have to check the ones that are square roots because those are the ones that if it's negative on the inside, then it's not going to work. Okay, so this gets you started on that assignment. I would spend some time to try to finish these problems from the last couple of days. And then I would either email me problems you would like me to go over or be ready to ask them tomorrow in the chat. But you need to make sure you're letting me know what questions you have. All right, so the rest of the time, you should have time for work.